Hello, my name is Colin Greatwood. I'm a part of the Mechatronics Application Engineering team with Festo, and today I'm here to show you how to set up an SMS IO-Link actuator over the CPX-AP-I-EC M12 network with an Omron NX1 PLC over EtherCAT. A quick overview of the hardware that you can see. I have a Festo 120 VAC single-phase in power supply unit. It supplies 24 volts DC out. Powered off of that industrial power supply are the Omron NX1 PLC, shown in the center left of the screen in black. The CPX-AP-I-EC M12 Fieldbus module, and you can note that I'm connected to the right hand or out port on that right now. Daisy chained over the AP network, which is the gray cable shown at the top of the screen, is the CPX-AP-I 4IO Link M12 module or submodule. And connected to port 0 of that IO-Link master, you can see the communication cable going over to our SMS IO-Link actuator. The variant here is the EPCE tooth belt. Now, a few other notes on connection. You can see all of my devices on the right are powered off at 24 volts DC. I have a Fieldbus connection over the Ethernet IP port 1, shown in the white cable on the top left of the PLC. I have my EtherCAT port, which is the bottom one, the very bottom of my PLC, disconnected currently, and I have my EC Fieldbus module for the API network. I'm connected to the right-hand Ethernet port, and that's connected to my laptop temporarily for initial configuration. The SMS logic cable, the gray one, is connected to port 0, as I mentioned, on the IO-Link master. Now I'll transition over to Festo Automation Suite. For the rest of this video, I'll be following closely the Omron application note that you can find on the landing page of any SMS actuator. I'll be making some deviations based on best practice that will help you with setting up your SMS actuator and your API network. So if you'd like to follow along, you can go to the device landing page and download that application note. All right, starting in Festo Automation Suite, you can see I have nothing detected currently. I'll connect to the light green Ethernet cable from that right-hand M12 port on the EC module and refresh to scan. You can see I immediately detect the EC Fieldbus module. If I expand it here on the left, you'll see some of the remaining topology, the IO-Link master shown here, as well as no devices currently, as I'm factory defaulted on the IO-Link master. You notice that the IP address by default is 1 in the 169 subnet. This is because EtherCAT is a node-based addressing system, not an IP-based addressing system. So the IP address that I have here, or that I will apply here, will only apply during setup, and as soon as I connect my EtherCAT communication to the PLC, it'll get overwritten here. So for the purposes of applying the app note the firmware is here, 163 and 166. I'll click on the EtherCAT Fieldbus module and go to my network settings down here on the right context menu. I will apply a 192.168.0, and I'll vary my last octet just for connection. Apply a subnet mask of 255.255.255.0, and then a gateway of 192.168.0.1. Then I'll activate my settings. And I'll acknowledge any and all pop-ups that appear on the screen. Once my network scan is done, you'll notice that my address is changed here. I can refresh the Festo Automation Suite to confirm that. I have an X over the status, and that's because my local network adapter is not accessible to that IP address. So I will go to Network Connections and set up that static IP. Going to the search bar, I'll type in network, view my network connection settings, double click on Ethernet. This is my physical RJ45 adapter. Acknowledge any pop-ups, and you'll notice that for detection, I had this physical RJ45 adapter at DHCP, or sorry, at a dynamic addressing. I will click apply a static IP address, and I'll apply one in the same range as the EC module that I just set up with the same gateway. Great. Now that I have that applied, I'll press OK, OK, acknowledge, close, and I don't need my network section anymore. By opening the command prompt, I can ping that IP address just to confirm that communication to the EtherCAT module will work. You can see I get that communication confirmed. I'll go back to Festo Automation Suite, and in the right-hand context menu, click Open Device Web Page. You can see this brings me to the device web page for the AP network. If I click on the IO link master, I can confirm a few of the settings that are required. The nominal cycle time for the port should be set to as fast as possible unless you're trying to optimize your network. Port 0, or the device port at the very top, should be set to IO link auto start. You don't necessarily need validation and backup for port 0. You can apply any and all of these settings for version 1.1, backup and restore if you wish. If you're applying backup and restore, make sure you have the nominal vendor ID set to 333 for Festo. And in my specific case, I have the device ID 607 for the specific EPCE that I have. But I'll reset those as I'm not going to be applying the compatible device check. I'm just going to do no device check for the purposes of today. Once those are applied, you can confirm them at the bottom once my Fieldbus goes active. One final setting here, you'll notice that based on the devices that are connected, the variant selection will be optimized. For an SMS actuator, if you only have SMS actuators on the IO link master, you can select variant 2 here. Make sure that you select a variant that is large enough by port, and this would imply 2 bytes of data in, 2 bytes of data out, and a PQI byte for an SMS actuator. If any other devices are non-Festo, make sure you have a variant selected here that allocates enough data for the connected devices. In this case, I only have one SMS actuator, and variant 2 is sufficient. So now that I've confirmed everything here, on my AP setup, I can minimize device port 2 and close the web server. Next, I'll go to my Start menu and launch the Festo IO Link tool. Once the IO Link tool has started, you can search for the master. Right away, you'll notice my EtherCAT master, the CPX-AP-I-EC, comes up, and I'll double-click it. That'll apply it to my topology here in the right-hand corner. I will click the play button here in the top of the dialog box. And you'll click Read from Master to synchronize everything that's on the IO Link master. Notice that now we have the IO Link on port 0 showing up as mode IO Link, and the other modes are deactivated for ports 2, 3, and 4. This is what we saw on the web server, but the vendor and device ID are not yet appearing in the row. We need to install the IODD file or the IO Link description file for the specific EPCE that we are trying to install. So I'll go to the web page. Here we are at festo.com, and I will search for the specific model that we have. Go to Downloads, Software, and note for description files, you'll click IODD, IO Link description file. Click Download. Once it's downloaded, you can extract. We'll come back to the Festo IO Link tool, right-click on IO Link, import IODDs. If I paste my extracted folder, you'll notice that I have an EPCE IODD to install. I can click on that device and import. After a few seconds, this IO Link catalog will be updated. You can expand it. We'll go into EPCE-TB. Now here it's important you get the right device type. Note at the top of the IODD file, you have your configurable part numbers, and then you have the ones of specific stroke length, and then some replacement old units. You can find the specific part number by looking at the side of your specific SMS actuator. I know that this first one, the configurable part number, is exactly what I have installed. I'll click and drag that. I have to click Go Offline, and then I'll click and drag that to this top rung. You can double-click the device. And if you want to be doubly sure, you can see that the product ID is shown here, and it matches the side of your SMS actuator, in my case, 8103354. Here's a quick view of where you can see that on the side of this EPCE. Here in the bottom right-hand corner, you see the word Festo with the type code and part number underneath it. Once you've confirmed that that's exactly the device that you have, and you've added the correct thing to this specific port, you can click the play button or go online. And you'll be prompted here to either read or write. This time, instead of reading from the master, we're going to write to the master. So now the master, IO Link master in this case, knows what device is at port 1. Additional settings can be pushed here for backup and restore if applicable. We can go offline with our IO Link master and EC network at this point, minimize, and you can leave the IO link tool open if you wish, but we don't need it any further. Now that we've finished configuration, you can see I have my Fieldbus connection connected to the right-hand M12 port on that AP-I-EC M12 module. I'm going to take a quick moment to transition it to the left and connect that cable to the EtherCAT port on my Omron PLC. Give me just a moment. Now that I've made that physical change, you can see my M12 connector is on the left M12 port on the EC Fieldbus module, and I have its RJ45 termination plugged into the bottom or EtherCAT port on my PLC. Now I'm going to transition over to Sysmac Studio. Now I have Sysmac Studio open. You can see I'm running version 1.6, and I have installed it via the 32-bit installer. I'll go here to the top left and click New Project. And I'll name it SMS App-Note. Great. I'll set it as a standard project. The controller category, my controller is an NX102-9000 variant, and I want version 1.50 as pulled from the side faceplate on the PLC. I'll click Connect. After I've clicked Create, I have my project now. I'll expand configurations and setups. Go to the built-in Ethernet IP settings under controller setup, click the TCP/IP section, and you can see here I will set my port to what I know my local adapter on the PLC to be, which is 192.168.0.10 with subnet mask 255.255.255.0. Then I can close my built-in Ethernet port settings. Next, I'll go to controller. Click Communication Setup. And since I know I'm connected over a hub, I'm going to click that option, or I'm connected over an unmanaged network switch. I'm going to type in the remote IP address that I've already configured and test to make sure I'm connected. When it returns test OK, with these two options checked, I'll press OK. Next, I'll return to Festo.com, and I need to download the EtherCAT description file for the Fieldbus node. So I'll type in CPX-AP-I-EC-M12, or you could have typed in the specific part number or type code here, part number there. Click Show Details, go to the Download section, Software, filter for device description files, and then download the EtherCAT XML. Once that appears, you'll download and extract everything. Once you've got it extracted, you return to Omron Sysmac Studio, and you'll double-click under Configurations and Setup, click EtherCAT, right-click on the master that's shown here, and then go down to Display ESI Library. Once the ESI library shows up, you'll click Install File, and you'll navigate your way to the folder where you unzipped the EtherCAT description file. Now, an important note here is you need to look at the side of your EtherCAT Fieldbus module. On the side of that module, you'll see noted the part number and the type code, as we mentioned earlier. You'll also see a Rev 01, 02, 03 up to this current point of the production of this video. You can see here by this picture that I have Rev 01. That's a physical hardware revision. And based on the hardware revision and the firmware you're running, you'll need to make sure you pick the right EtherCAT description file. Now back to the folder we were looking at. You can see here, if I go to this very specific folder where I unzipped everything, you'll find this README text document that explains this next part. In the README, you'll see that starting with firmware version 1.7.3, and that's of the EtherCAT Fieldbus module, there are some changes, and you need to use this latest version that you can see here, the EC20241106. Now, if you're running hardware Rev 1 or 2 and firmware that is older than 1.7.3, which if you recall from earlier in this video, when we were looking at Festo Automation Suite, the firmware I had installed is 1.6.3, 1.6.3 with a long extension. Because of that, I need to use the ESI file that's a little older, the R1, R2, 2024-11-06. So make sure you're picking the right one for your hardware and firmware compatibility. So now that I'll go back to the ESI library file selection, and instead of this file that's in the root of the unzipped folder, I'll click in and install the older version, the Rev 1, Rev 2. I'll click Open and click Yes. You'll see installation in progress. You can see my installation fails here because I've already installed this file. So I'll press OK. You can still note that the file installed correctly if you go to the bottom of your ESI library, and you can see Festo CPX-AP-I-EC R1, R2, just like in the title of that description. And within that, you have the Rev1 of the API-EC Fieldbus module, the Rev2 of the API-EC Fieldbus module, an EX2CS version, which most people will not order. It's a very different part number. And then the APA-EC Rev2 as well. So if you have Rev3 or newer, please make sure you're not using this file. Now that I got it installed to the ESI library, I'll click Close. And by expanding the toolbox in the top right with EtherCAT still selected, I'll scroll down to AP, select that at the top of the group, and you'll notice that here I can select the version that I have. In this case, I have a CPX-AP-I-EC M12 Rev1. I'll click and drag that to connect with my master. Next, I'll enter the node address here, making it 1. It's important to double check this later. So we'll come back and make sure that the node address is set to 1. If you'd like to do so now, you can right-click on the master, and by connecting to it, you should be able to write slave node address, but we're not going to do it right now. We'll do it a little bit later. By selecting the EtherCAT Fieldbus module here in your EtherCAT setup, on the right-hand context menu, you'll click Edit Module Configuration Next. Now we need to configure all of the modules that we have selected. If I go back to my camera view, you can see I have 2 CPX-API modules. First is the Fieldbus on the left, and then second we have the IO-Link master module on the right. So from the available library, I'll scroll down, or you can filter by typing in the beginning of your type code string. In this case, I want the EC module, as we mentioned earlier. I'll click that and drag it to slot 0. Next, I'll go back and I'll add my 4IOL-M12 module. Note here the different variants. As we discussed earlier, you need to make sure you're allocating enough data for all of the devices you have connected. If you only have SMS connected, SMS I-Link actuators from Festo, you can use the variant 2. That will suffice for the data that's going to and from. So here, I'm going to use the variant 2. For the EC module, if I click Edit Setting Parameters, you can see there's really only one default, and this is also reflected in Festo Automation Suite. I could have configured it there. It's important to check this and make sure that this is the setting you want. The default is what I want in this case. For the 4IO-Link module, go to Edit Settings for this, and you'll notice that a lot of these settings that are default differ from what we configured in the Webserver. So for this, for port 0, port 1, 2, and 3, I don't really care about since I don't have a device connected to it. You want, again, as fast as possible, set to port 0. I want true set to detection of IO-Link device lost. Port 0, instead of deactivated, I'm going to set it to IO-Link auto start, just like I did in the Webserver, and I'll leave the other 3 deactivated. And then for port 0, I can do no device check or any of the version 1.1 going forward. So for right now, I'm just going to set this to no device check. You'd also need to, for the device check, to plug in value 333. And then your appropriate SMS value here for device ID. 607 note is specific to the EPCE tooth belt. So I'll leave those at 0 since I'm doing no device check. And I'll click Apply. And OK. One final note, it's a good check here at this point to make sure that all of your modules are the appropriate type. Make sure you don't get the API versus APA mixed up here in the submodules as well. So in my case, I'm using all API. We're all good. The port data size has been set, and all my hardware stuff checks out. Next, I'll go to the I/O map. By expanding my EtherCAT network config, I'll drill down into my IO-Link master. And you'll notice that I have, just like I said, from variant 2, I have 2 bytes, bytes 0 and 1, assigned to each port for outputs, and then 2 bytes for inputs, and then 1 byte configured as a USINT for the PQI or device available. In this case, I want to set up some tag names, just like it suggests in the application note. I can type in the exact same name as in the application note, output_ch0, and press enter. It automatically adds that to global variables. I'll do that same thing for the inputs. And I'll do the same thing for the PQI. Note that it says port 4 here for inputs port 4, but this PQI 5 is specifically for port 0, device port 0 on the IO-Link master. So don't get confused by the nomenclature. Once those three have been added to global variables, we can now go to the project menu, go down to Library, Show References, and now we need to import our two libraries, one for the AP-EC and one for the SMS. So I'll click plus, navigate to where I extracted the application note, and I'll drill down into the subfolder 3 for libraries, and I'll import both of these one at a time. So the Festo CPX-AP-I-EC, and then I'll do the same thing for the SMS_Festo library. And then I'll press OK. I'll confirm that that was added to the library later. I didn't get any errors or warnings. Next, I'll go into my programming section and go down to POU's Program Section 0. Double click on Section 0. Notice in my toolbox, I now can see the two libraries we looked at earlier that we just installed, the Festo CPX-AP-I-EC library and the SMS Festo library. I'll expand this SMS Festo library and click and drag the SMS Advanced into rung 0. Once you've got your function block added, you can type in the name for the block. And if I expand my variables header just a little bit, here we go, with internals selected, you'll see that get added to the internals list of the correct type. Now for the input channel, we're going to use our selection that auto pops up from the global variables list, but we're going to select not the 0th byte, the first byte in that 2-byte array, or the last one, really. And we're going to do the same thing for the output data, pick output CH0, and then byte 1, or the last byte in that 2-byte array. And then the third address that we'll add is the device available address. Perfect. So now for the EtherCAT address here, we'll just name it like the function block, and we're going to name everything for internal variable, and it sets it up for the correct type, uint. I'll quickly do this for the remaining variables, for the input tags and the output tags. Wonderful. Now that I've got all of those tags created, and you can see them all here showing up in internals with the proper data types, and this matches pretty much one-to-one the application note. Under externals, I just have those three that we referenced at the top of the function block here in input channel, output channel, and device available. The last piece that I'll add here on my rung 0, and it's my only rung, is I'm just going to create a normally open contact here and title that enable block as an internal. Let's make sure that that shows up as a Boolean type. Very nice, showing up as a bool. Now I'll click the little triangle here to go online. Great, you can see I'm online with the PLC here at its first Ethernet port, Ethernet IP port, and there's 2, as you can see. The next thing I'll do is click transfer to controller. Here it's a little download to the device, and because we've got some hardware setup stuff in place here, I do have to uncheck this third box that shows up by default. So the top 3 should be unchecked, 1, 2, 3, and the bottom should be checked as the Ethernet IP connection setting was already verified when we did the test OK earlier. I'll click execute and wait for the transfer to complete. Okay, you have to acknowledge this pop-up, says the EtherCAT slaves will have to be reset, forcing the node addressing. We'll acknowledge those. And we get this last pop-up that says cycle the power supply to the slave devices to apply the settings. I'll press OK. It says successfully completed. And we've transferred everything to the PLC. Now, at this point, it's worth noting, if I go back to EtherCAT, something to check here is if the node address has been transferred, right? We set up node address 1 for the EC Fieldbus module. But if I right-click on the master, I can click Write Slave Node Address, and it pulls the live system here. So update with latest actual network configuration. If for some reason the node address that's showing here on your device that's saying present value doesn't match what you're presetting here, you can actually come in and double click this and write in specifically whatever node address is required for that node. Obviously, in this case, I want it to be 1, so I'm not going to write this. If I change it to 2 here and click write, then it'll apply that node address, but I don't want it to do that. I want it to stay at 1 because that's correct. So I'm not going to press write, but you can force it. You'll notice when the node address matches, you get this little play button, play icon here, and it says matched. If it doesn't match and it shows up as a default, you'll see this as node address 0 when you check that present value, even if you have the node address set to 1 here under the specific EC Fieldbus module parameterization. So you might have to do that write slave address component. Now that we know that our Fieldbus looks good, everything's enabled, we have some presets that we need to write to this block for things to work as expected. I'm going to go offline for a moment. And I'm going to preload some values into my top tag table here under the namespace. The ones you'll see in the application note, EtherCAT address. We just confirmed for the EtherCAT Fieldbus module that this EtherCAT address needs to be 1. So I'm going to type in initial value 1 here. The next piece, slot number. Even though if you go back to the actual node configuration, you'll notice that we're trying to point our communication for this SMS function block to the IO-Link master. You can see that it's addressed here as node 1 for that IO-Link master and the SMS we're trying to communicate with. So you'll take that node number and add 1 to it. So going back to the program, I'm actually going to put in not slot 1, but slot 2, and that will communicate with the correct number. Now for port, I have 4 ports on this device, and if I only have one IO-Link master, as I do here under the EtherCAT node, I only have 1, the port numbers there are going to be 0, 1, 2, or 3 for this 4-port device. System connected at the top one. As you can see in the device hardware, I'm going to type in port number 0 here. So 1, 2, and 0 will communicate with the SMS that you see configured in the video. Now, with those presets in place, I'm going to go back online. Once I get my online state, I'm going to put my PLC in run mode. And I'm going to enable my block here to true. Now you'll notice I get a device available error here 64. You want this to read 160. The primary reason for that, if I actually look at the SMS hardware, is you'll see that my device is not yet ready. And if I actually go to my top view, you can see that my port 0 device LED is actually showing up as red. Sorry, it's obscured by the cable a little bit here. So that error is occurring because of the power up sequence. So make sure you're powering up the load and logic power in the proper sequence. Since I don't have any relays here, I'm not powering them up in the proper sequence. They're just coming up at the same time. I am going to clear that error manually. So I've cleared that error manually. And you can note on my IO-Link master at port 0 that I now have a green light. So since at port 0 on the right-hand side, I have a green light. If I go back to my program, you can also see here at my device available input, I have value 160, which means my device is available. And you'll notice my input channel also updated to value 0A rather than value 00. So I'll override my EtherCAT address, my slot number, and my port number, so everything's communicating. And then I will either do one of two things. Refresh the block enable, and then my quit error bit down here at the bottom, I'll press true and then false. Notice that you get an AOI error of 1003. If you pull up the documentation, you'll notice that if you get a 1003 error, that's because some of your values are preset to value 0. You'll note down here speed out, speed in, force, and some of my positions, position start press, the in position out, and my intermediate position are all set to 0 values. So in this case, if you look at my part number, from earlier, you know that I have an actuator with 20 millimeters of stroke. Since the positions are all scaled up by a factor of 2 places, or 100, if I type into position start press, I'm just going to override all of these to my maximum. So 20 millimeters here, noted as 2000. Do the same thing with in position and intermediate. I'll also need to put values into speed. So this is a 1 to 10 base value, 10 being 100%. Speed, we'll set that to 100%. Speed in and out both, and force if I was using pressing mode, which I'm not in this case. Oh, sorry. Force needs to be 10, not 100. Great. So now all of my pre-loaded positions look good. If I quit my error here, you'll notice that my AOI error cleared by itself, actually. I can toggle that if I'm concerned, the quit error. And now I no longer have an STS error, AOI error, and I don't have any IO link error, event code, or IO code down here at the bottom. I am at my current position. It's a max of, for 20 millimeters. I'm at 21.66 millimeters. I'm all the way out in my stroke. And if I bring in the side camera view here, you can see I'm at 21 millimeters. If I toggle my move in, you can see it extends. I toggle my move out, it extends or retracts all the way inward. If I move back in and then move intermediate, you'll notice my intermediate is effectively the same position as my out position. Reading here at current position 2000. But what I can do is I can change that intermediate position real quick. Let me move back in. And then I am going to change my intermediate position down here at the bottom, and I'm going to make it about halfway, so 10 millimeters. And I'm waiting for the write done. You can see that that just flashed true here at the top. After about half a second, usually is how long it takes to write, I am currently at my in position, as noted by state in here at the top. If I move intermediate, you'll notice I get state intermediate is true and out is not true, and my current position is halfway. It's about 10 millimeters. So I'll turn that off, and I can continue extending using the move out. See, I get my state out bit is true, and my current position is set to 20. Obviously, I'm leveraging here the move in, move out, move intermediate, quit error. Those are all the process data bits that we've just walked through, and the control, those are the control bits, and the status bits, state out, state moving, state device, and state intermediate and state in. Those showing the 3 unique states that are achievable. We also showed the message instruction here, or the embedded mailbox feature of IO link, by changing the intermediate position from what appears after reference, which is the maximum or out position, to halfway. So we change that from 20 millimeters to 10 millimeters. I can, as one final demonstration here, I will slow my speed out and in down considerably. So again, we wait for the write done bit to be true for those, and you'll note now that my speeds are significantly reduced. Let's do that one more time. We are currently out, so I'm going to toggle my move in bit, and then move out. Very nice. If you have any additional questions about how to set this up or improvements in the libraries, feel free to reach out to your Festo application engineer. Thank you very much for your time.